Ladies and gentlemen, hello, and coming to you not quite live from One Take Studios, where today we get to talk about applications of quadratics. There are so many really good applications of quadratic models, and there's one in particular that I would like to focus on today. I call it the projectile application. It doesn't have an official name that I'm aware of. If you happen to hear of one, let me know. But, grand reveal, dun 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 dun! That is it right there. I decorated it in red and orange and little green tiny smiley faces, if you can see those there. Ladies and gentlemen, this is a major formula that shows up frequently in math textbooks, and it's just really fascinating the way it all comes together. So I would like to spend our time today just analyzing this one equation and what it might mean. Alright, so we have a whole bunch of variables here. First of all, based on my handwriting, that is a cursive letter T. It's not an A, it's not a star, it's a cursive letter T, because I don't want my T to look like a plus sign, and my handwriting is not good for cursive, so that's what you get stuck with. There you go. Alright, so what do all of the pieces parts mean? Let's take a look at this, shall we? We essentially have four things going on here. T oftentimes stands for time. So we have T in time, and with this particular problem, this happens to be in seconds. So if we're talking projectiles, something gets launched, psh, boom, the time that it spends in the air as part of that process. Now you'll notice there's a V sub O and an H sub O. Both of those have this. This is a common notation in mathematics, especially because here I have two different H's, and I want to be able to tell them apart. Anytime that you see a sub O, sub zero, this is the starting something. In this case, it's the starting height. In this case, it's the starting velocity. I'm going to call it the initial velocity. That's what initial means. So this is our initial or starting velocity. What is velocity? Fancy word for speed. Very good. And our initial height. So we're talking how long it takes starting at a certain height based on a certain velocity. Am I dropping something? Because if I'm just dropping it, what's my starting velocity? Am I throwing something? Am I hurling it through the air? Then what's my starting velocity? What if I'm playing volleyball and I spike it towards the ground? Ooh, that's not going up at all. What might that do to my velocity? These are all things to think about. Initial height, that's kind of the more obvious type of thing. I'm going to start from somewhere, and then my object is going to move. What about this, though? Notice this is a variable. This is not h times t. This is function notation. This also is height, but it's not the starting height. This is the height after time has passed. So the height after t seconds. The height after t seconds. So in other words, this thing gets launched in the air 1 second later. What's the height? 2 seconds later, what's the height? This gives me my height as the thing is traveling through the air. What goes up must come down. That always makes a parabola. So whether this be a sport, basketball, volleyball, soccer, what else is in my brain? Baseball, or this be you launching water balloons at somebody through a delightful cannon. All of these things are projectiles, and so this particular formula applies to all of them. So I want to start with this equation right here. I've got h of t equals negative 16t squared plus 20. Let's see if we can actually figure out some meaning of this based on our understanding. By the way, notice the negative 16 is still negative 16. I'm going to apologize to all the physics people out there. The negative 16 is going to make this parabola open downward. This pertains to how things fall and move through gravity. So I call it the gravity factor. That's probably not the official term for it, but that's what's happening here. Based on how things fall, this is a physics thing. It will always be negative 16. So, based on this, I have a negative 16. I don't have this middle term right here. So what must be my initial velocity? If it's 0t, if I don't see it, my initial velocity was 0. This thing was not hurled. This thing was dropped. Its starting velocity was 0. It had no speed when it was dropped. But this, the 20, the constant, means that it started from 20 feet in the air. So if I just want to do a diagram of what that might look like, let's think about this here. Let's call this 20 feet up and something was just dropped off the side. Dropped off the side of a roof, who knows? Maybe you had a really tall ladder. That's a parabola, is it not? Some of you might be going, well, yeah, but where's the other half of the parabola? Oh, it's there. It's over here. That's the other half of my parabola. However, if I'm talking about life, usually we have positive times and positive distances. And so oftentimes we are only looking at the part of the parabola falling in the first quadrant. And what would have happened back in time is not part of this. So this starts at a height of 20 and falls. That's all this is right here. Starts at a height of 20 and falls. Would this keep going? Yes. Do I care about that part? Not really, unless I'm dropping something perhaps below sea level, but that's going to change how something falls, or if maybe if I'm dropping into a hole in the ground perhaps. But this would be my ground level right here. The number 1 and 2 questions that are asked, and I suppose there's 3 technically, about this particular type of problem is they want to know what's the maximum. You see the word max often. And if they ever asking you for a maximum, this is a parabola. This will always be a parabola. They're asking for the vertex. So either in the problem you are looking for the maximum, the vertex, or they will ask you fun questions like, when does it hit the ground? When does it hit the ground? What would that be? What is my height at this point? 0. Ground has a height of 0. And so that means that if we're looking for this, for our parabola, we're looking for our zeros. So most of the time we're either looking for the vertex, which is our maximum, or we're looking for the ground, which is our zeros. That covers most things. Think for a second what is on this particular axis right here, what this would be. I'm skeptical about putting actual numbers in place here because I don't know. I just kind of sketched this thing here. But if we're looking at this, this is going to be my time. So this is the amount of time that has passed. And then this would be, turning this sideways for a second here, this would be my height. And so this particular model tells you how high it is based on the amount of time that it's been in the air. This particular formula does not do any other combination. It doesn't tell you how far and how high. That would be a different model. This specifically ties together time with height. Okay? Let us ponder life for a second here. And let's say that I've got, let's make something up. I like the name Bertha. Bertha throws a pumpkin upward from a height of 10. Let's go with a 10-foot deck, shall we? At a velocity of, this might be completely unreasonable, but hey, it's kind of fun. Let's go with 32 feet per second. 32 feet per second. Ooh, feet per second squared, is it? Nope, just feet per second. There we go. All right. Great. We have an application problem. These terrify people, but they shouldn't. Based on what we know here, what can we set up? We're looking for what might the height be after time has passed. We know that due to gravity, this -16 is a constant factor for us. So -16t squared. We know the starting velocity is 32, so plus 32t. And then, well, how high is this? Do we want to say 10 feet? Picture. All right, here's our first quadrant. Here is Bertha's 10-foot deck. If you were launching it from 10 feet, and you were Bertha, and you were standing on the deck, would you actually be launching it from 10 feet? Probably not. Bertha is 5 feet tall. So she's 5 feet tall, standing on a 10-foot deck. And now she launches it. Again, this is a sketch, not drawn to scale. That's okay. What do I want to put here? Assuming that Bertha actually has a height, and she's not launching it from the actual deck surface, 10, and then another 5. This is being launched from 15 feet in the air. And because it had a starting velocity, she didn't just drop it like we did, so it's not just going down. She's throwing it up first, and then it's going to come down. Again, questions that might be asked as a result of this problem, they might say, hey, how high did this thing go? So let's say that there's a bird flying by in the air, and I would like to know, that's my bird, I would like to know if there's any chance that Bertha hit the bird with the pumpkin. I would want to know my maximum. I would want to know my vertex. I can find vertex, either opposite of b over 2a, or possibly through maybe analyzing one of my graphs on my calculators. Maximum is the vertex. I can find that. If I want to know how long until it hits the ground, how long until hits ground. Again, what am I looking for now? Hitting the ground has a height. It is a height of 0. Now I'm looking for my zeros. So know what the question's asking, because it'll guide you one of these two places most likely. The only other option that you might see from time to time is, let's say for the fun of it, there was a fence out here someplace, and I would like to know if this particular fence was cleared by the pumpkin. Did the pumpkin make it over the fence or not? This is not the highest point. It's not the vertex. This is also not 0 because it's not the ground. I'm trying to see, did it clear this particular place? So they may be asking you for a point along the way. And if I happen to know the height of the fence, so let's say that the height of the fence happens to match this one. So let's say the height of the fence was 10. I might go back to my equation and say, all right, I'd like to know how high this was at this point in time. And I might plug in, if I know time, I might plug in t, height, I might plug in h, and see if it cleared the fence or not. So occasionally they will ask you for a point along the way, but usually they're asking you for something having to do with the highest point or something having to do with the zeros. Alright, so I did not go through the specifics on how to solve this because that is a different video, different time, and that's stuff that hopefully you've already seen and heard. But I want you to see this, and I want this to not be a mystery for you. Every piece means something. The pictures always match up with what's going on. Know if you're looking for the vertex, know if you're looking for the zeros, and make it all make sense. Alright, thanks guys.